Hi there, everybody. My name is Dominik Roszkowski, and today we're going to talk about animations and some ways to improve your skills when using them. And I hope that this talk will give you some kind of inspiration and some maybe tools to help you make your animations nicer, develop them faster. So this is not like a tutorial presentation. There won't be like a lot of live coding, but I'm going to show you some code. But in general, what I want to convey is some kind of different approaches to how you can actually use animations in Flutter. And because the spectrum of possibilities that you have in Flutter is pretty wide, so you all know about some basic implicit, explicit animations, maybe animation controllers. So I assume that this kind of knowledge or some basic understanding what kind of animations can you do in Flutter is already something that you know. However, I will go also into some basics just to give you some grounds to understand what we are going to talk about. But in general, my idea is to inspire you, to show you what kind of different approaches can you use in your Flutter apps. So let's start. Oh, maybe let me just also tell that I'm working right now at VGV, Very Good Ventures, and we're actually looking for some people to join us. So if you know Flutter, even only a little bit, please check out our website for more information. So, as I said, goals for today is to have an overview of animation approaches. I'm going to show you some tips and tricks, some code, how to actually maybe organize your animations in some more maintainable way, and give you some sources for inspiration, maybe some examples. Let's start with the basic stuff that's always when you have animation presentation is a distinction between implicit and explicit animations. So let's start actually with an example. So implicit animations are the ones that happen in some kind of response to your action and where you don't actually have to create any animation controller. They just occur between changes of some state, changes of some property, and actually, we say that implicit animation means that some property of a given object, it can be like its opacity, it can be its layout, it can be its position, or any other actually property is changed from one to the other. And Flutter and its internal logic will take care of interpolating the value between one and the other. So in Flutter, we have a bunch of different built-in implicitly animated widgets. So in this short list, you can see animated opacity, container, crossfade, switcher, physical model. And let me actually show you a short example. So I also prepared a small desktop application in Flutter so that we can experiment a bit with all of these animations that we're going to talk about. So here's my app. We're at the stage of implicit animations, and let's maybe just check out this animated align widget. So when I click at the button, the only thing that is actually changing is some random alignment applied to this text button. So if I click, it changes to some random value. And as you can see, the transition between position or the alignment of this widget is being interpolated automatically. So I don't have to actually do any sort of calculations or interpolation on my own. This is done purely via Flutter and its ability to interpolate two values from one to the other. Also, there is very convenient widget, and it allows to actually interpolate much more properties than just position, which is animated container. And when I click animated container here, some properties change, and I'm going to show you in a minute. But as you can see, many different things can change implicitly when I click the button. The same happens here. This is actually animated physical model, and animated physical model is something that is like a base for all the material widgets. So it means that it just has an elevation. Thus, this is physical because this has elevation and it casts a shadow. So when I click this, some properties change, and this makes them interpolate between. So let's just quickly take a look at the code that is that was used to make these animations. And what I do here is that, for instance, in case of this button, I just change between 120, 170, and 500 size. And maybe the radius is also changing 0, 16, 190. Yes, 0, 16, 190. The same for elevations and colors and so on. But the most important part is a bit lower. So for instance, here is my animated container. And I just apply some sizes, and I apply some color and some more stuff, just in order to have a very convenient way to animate some properties. And this is something that may be used by you very commonly in your Flutter apps. And actually, just from some implicitly animated widgets, you can create very complex animations. However, so for instance, here we have animated align example, and the only thing that is changing is this alignment here, right? Sorry, I didn't mean to click it. The only thing that changes is alignment. And for instance, this is how it looks like for a different widget, in this case, Flutter logo. Here I have my unpressed, some random numbers are being applied to the alignment, and that's all that we have to actually do. However, sometimes the built-in implicitly animated widgets are not enough, and there is very handy base widget that we can use, which is called implicitly animated widget. And actually, all the other implicitly animated widgets are using this. But sometimes when you, for instance, want to animate something different than just some basic container property or basic position, you can use this base widget to create your own implicitly animated widget. And this is very helpful thing to do. And on this slide, you actually can see the full source code of this widget that you see on the right side. So in this case, what happens is, for instance, when you have like an upload indicator or download indicator, and you, for instance, get some data which is discrete, so you get like 01, 02, 03, 04, and none of the values in between, and maybe you want to make this animation a bit smoother, so we can use the implicitly animated widget to make it appear like fluid, make it more fluid, make it appear more smooth. So what you just need to do is to implement or extend the implicitly animated widget. And actually, what happens is that it has its own state. So you have to also create a state for this widget. And in your build method, you can use use a tween that is being created in a method for each tween. So you have to implement the method for each tween. And in this method, you have the another method, which is a visitor, that you have to use in order to create your interpolated value. And in my case, what I do is that I just create a tween of double, and we're going to go into the tweens in next slides. But what important is right now is that you have to create your tween, and you just need to provide this value as a begin for this tween. And then you can just use this in your, for instance, in my case, in circle progress indicator. The API for this widget is a bit strange. So for instance, if you want to provide a constant color, you have to provide this always stopped animation, which is very strange. But also this makes it so that you don't have to create animation for a color. You just need to provide a value as a value of your tween. And let me show you this in like the example. So again, if I tap here, this animation is a bit smoother than if it were like without implicitly animated widget. The source code will be shared with you after the presentation, so don't worry, you can then take a look here and see for yourself how it's done. But now let's stop actually at this and move to the next type of animations, which are explicit animations. So explicit animations are these like more powerful, more complex, and actually they require more of your attention, more of your consciousness in order to create them. And what happens is that you actually need to drive your animations in some way. Most commonly, you would use animation controller. However, you can use also some other ways to drive your animation. And when you use these animations, or when you drive these animations, you can use some very handy widgets like scale transition, size transition, fade transition, animated widget. They all accept animation and allow you to um, um, use this driving force that you've created with your animation controller to make some changes. So let's go back to our sample application. And here are actually a bunch of explicit animations that I prepared for this presentation. And here we have, for instance, some avatar with some glowing background. We have Flutter logo that is being animated. We have Slack logo that is being animated, some loading dots indicator, and some pulsating or pulsing icon here. So a bunch of different animations. All of them are like some kind of micro interactions or some kind of, let's say, decorators, right? They are not like game animations where you have some kind of engine model or whatever. They are all like if you were to use them, they would always be somewhere on the side of your app. Yeah, they wouldn't be some main um, element of your layout. But of course, you can also use explicit animations for that. But for the simplicity of these presentations, and also that because of I had these animations on hand, I'm gonna show you some examples of them. So maybe let's take a look at this very simple animation that we have here, which is this glowing icon. And I'm not sure if it's this. Yeah. So in case of very simple animations like this glowing icon here, there is not much that you actually need to do. Of course, many people would say that this is pretty cumbersome and there is a lot of boilerplate with animations. But frankly, all that you need to do is this, like maybe 10, 20 lines. Of course, you can maybe create some snippet for that, which I recommend to have a snippet so that you don't actually write this manually. But the point is that you always need to have animation controller. You have to create this animation controller. You have to use ticker provider state mixin or single ticker provider state mixin in order to provide a ticker into your animation. And you have to provide some basic properties for the animation controller. And you always need to remember about disposing this animation controller as soon as the widget is being disposed. However, the animation itself is very simple. Like there is not much to do. Yeah, but I find I find it very interesting that, for instance, in this case, it's like not so trivial how you actually implement this kind of glowing animation, because when you think about this kind of behavior, it means that like something is being extended and then shrunk and extended and then shrunk. But you think many people tend to think about it from the inside of the widget. But for instance, in my case here, what I've done is that I actually am shrinking padding. So I'm not making the container bigger or smaller, but I'm actually changing the size of a padding around the container, which means that actually I'm just like making the margins or paddings around the widget smaller or bigger. So, and this makes Flutter to like extend or compress the widget that is inside of that. Yeah, and my widget inside is just this decorated box. And I'm using animated builder. We're going to talk about animated builder in a second, but the most important part is that here, this like trick that I often share with people, and the same happens also here in this more complex animation, where I have like a bunch of this overlaid circles. And what happens here is that I'm also changing the padding around them so that this appears to be glowing. Another interesting approach to explicit animations is actually to not use the animation controller, but something different, which is a timer. So let me show you this actually in this example. So this dot indicator that you can see here on the right side. Here we have 5 dots, and what is like very how to say it, what is very distinct about them is that I couldn't find an easy way with animation controller to actually like animate this kind of change that you have like a bigger and smaller circles going across the screen. So what I came up with here was to actually use timer, and timer that has some period, and on each of these ticks, or on every period of this timer, I'm actually, what I'm doing is that I'm just switching the index of the currently active or big circle. Yeah. So period one, this, maybe let's actually make this period a bit bigger, and how to restart my app. So when I made this a bit longer, you can easily see right now that on each tick of this timer, or on each period of this timer, the next index is being selected. So this is 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. And there is also some logic. Yeah, I need to always get a modulo of the elements. I need to remember about disposing the timer. And then I just have my dots. So each of this widget is a dot, which accepts its size, like default size. Yeah, so there is some kind of default size, and also which index is currently selected. Sorry, here, currently selected, and which index has the given dot. And here I combine something that we've learned before, so implicit animations, and my current approach, which is explicit animation. Yeah, so I explicitly say which widget needs to be bigger right now, and I just go through them one by one. And what I do, I just use animated container. So actually, I don't have to now animate the size of the widget itself. I just use animated container, and I'm using this fraction that is being calculated here, and there is also some logic behind it because I want to uh, decrease the size of the next and the previous circle, right? So as you can see, the middle one is being the largest, and the next and the previous are being a bit smaller. But this is like only a detail. The point is that I'm combining both of these tools here in order to create pretty pleasant animation, right? So this is not something that you maybe wouldn't like to see in your app. Yeah, it's actually that something that is not obtrusive, is pretty nice to look at. And if you want to see some details about the rest of the animations, I encourage you to check out the source code later. So let's recap the animation controller. This is for the backup slide here. Animation controller. We need to initialize this in init state, and then we need to provide it to animated builder. And animated builder is a very handy widget, and you've seen that I've used this at least once right now. And animated builder is a widget that helps you to actually use your animation controller in a most efficient way. So what animated builder does is that it accepts a listenable. So listenable can be anything. It can be change notifier. It can be any other listenable. But in practice, you will almost always use animation controller, and animation controller tells animated builder when it needs to rebuild. And when it needs to rebuild, it will just run its builder function and will keep the child intact. So as you can see on the slide, there is a builder parameter and there is a child parameter. And the child is being built only once when the animated builder is created. So for instance, in my case of this previous animation, the icon and the decorated box wouldn't be rebuilt. The only thing that is being rebuilt is this decoration, shape decoration that we have here. So always when you use your animation controller, don't add listeners to animation controllers. This is what I've seen a lot, that people add listeners to animation controller and set state, but just use animated builder. The next topic that we're going to tackle today are tweens. And actually, when you Google for tweens, there's like different strange things showing up. And even on Wikipedia, there's like a bunch of different articles about it. So I'm gonna quickly introduce you to the tweens and how can you use them in your Flutter apps. So tweens are like classes that have very handy properties or functions that allow you to interpolate values or map them between the initial value and end value for a given progress of animation controller. So you can imagine animation controller as some kind of clock that goes from 0 to 1, or you can also specify different ending value, but by default it goes from 0 to 1. But in reality, not many animations go from 0 to 1. Usually they go from, like in my case on this slide, from offset 1 to offset 2, or they can go from color red to color blue. They can go from radius 21 to radius 97 or whatever. So usually it's not so simple that animations go from 0 to 1. They usually have some different values, and also usually they don't go from one value to the other value linearly, on linear basis. Yeah, they follow some different curve, we say. So they have some different acceleration and deceleration than like simple 0, 1, 2, 3, 4. They usually have some kind of physics simulation or some kind of behavior applied to them. So for instance, when you open your screen, you have some kind of fast animation at the beginning and slow animation at the end, or something similar. And tweens allow you to actually map from this animation controller value to some more usable representation of that. And you can use tweens in two ways. So you can think about it in like some kind of a different perspective or relationship. So either you can create a tween from the animation controller. So on the left side, you can see that I just have some kind of animation controller, and on the animation controller, I just supply a tween to the method drive. But you can also have a tween somewhere in your app and animate the tween based off of the controller. So both of these ways are correct, and I always had problems which one to use. And finally, I just concluded that this is more obvious to me, but you can also use this, these are equivalent, and you can use both of them. And I also mentioned about these curves that you can use with your tweens. And in order to actually convert a simple linear tween to some tween with a curve or based on curve, you actually need to use something called curved animation. And I also had some problems with that in the past, and I remember that I struggled to understand how it works. But in essence, it just means that if you have some kind of linear curve from 0 to 1, and you can see actually on the top from 1 to 0, you can see that this is straight line. And if I convert this with a curved animation, in this case, I think this was ease in or decelerate, it just makes this curve and actually the movement of this element a bit different. The same happens if the curve is a bit more, let's say, original. Let me show you this on an example in the real app. So I also have a sample. And for instance, here we have 4 of different curves and tweens. And as you can see, the blue one goes linearly. The red one goes with a curve called decelerate. And this is similar to, for instance, iOS elements on UI have. Yeah. So for instance, when you open something on iOS, it's often using the decelerate curve. Then you have elastic in, elastic out. This is maybe useful if you have some kind of a bouncing ball or something like this, and you want to have some kind of elastic behavior. And also the bouncing out also shows some kind of reminiscence of some kind of physical object, right? The orange box goes to the right and bounces off of the wall, and this looks more or less of some kind of physical object. So as you can see, you can use Tweens for that, and let me actually show you how I've done this simple thing. So these are Tween, not this. Here, Tweens. Yes, so what I do here, I just create a tween. This is very basic tween, so this is the first one on the top, which is linear, right? And I can also create a curved tween. So what I do, I just apply curved animation. So instead of using actually controller, I provide a controller as a parent to this curved animation. Yeah, later we'll see some more complex usages of that, but at this moment, let's just stick to this. And then when I have this get curved tween, I just, in my animated builder, and again, I'm using my animation controller as an animation that is supplied to animated builder. And then I just get the position for a given curve here. This is not optimized code, so bear in mind that actually I'm creating this tween on each build of this animated builder, and like this is not the perfect approach, but what I found is that especially during the development, so this is another, let's say, tip and trick, especially during the development, it's not worth to create a tween as a, like, let's say, static property on your class because it doesn't change, because this would be some kind of performance optimization. But actually what is very helpful, especially if you just want to tweak your animation, see how it looks like, is to create this inline with your animation or with your widget, because this gives you this like fast development cycle so that you can quickly iterate on the animation. And then when you're like ready, you can extract this and make this like a static field on your class so that the tween is not being recreated every time you ask for that. Yeah, because here, as you can see, this tween is being recreated on each call to this function and so on. So it's a bit inefficient in terms of object creation, right? Or memory consumption. So again, tweens are very useful, and there's also some handy widget that can help you to use tweens even without animation controllers. So as you've seen in a few seconds ago, I had to create animation controller, and from this animation controller, I had to create my tween. And frankly, this gets a bit complicated with time, especially if you just have some kind of small thing to do, and you don't want to like make the widget stateful, and maybe you use some kind of different approach like provider or hooks or some different approach that prevents you from easy usage of stateful widgets. So what you can do in such cases is use the Tween Animation Builder. And Tween Animation Builder is like this helper widget that allows you to animate value from some beginning to some end. And then also what is very interesting, it allows you to animate from this ending value to any other value that you provide as an ending value. And I'm going to show you in a moment how what I mean. The nice thing about tweens is that tween can be anything. It can be number, it can be offset, it can be string, it can be your class, provided that you provided linear interpolation method, and it can be a color, it can be a text, it can be whatever you like. And there is also this point that tweens can be mutated, because when you create a tween, you can change its properties. So you can change its end or its start to any other value, and this will cause the animation to actually go to this value that you've just set. So in this case, you will see this in a real example. So let me actually switch to this page. So here is my Tween Animation Builder, and this Tween Animation Builder is actually very simple. So here is the widget, right? Tween Animation Demo. What I have here is just my child, which is a text, nothing fancy. And then I have my Tween Animation Builder. I have some basic duration, which is necessary. I have my tween, which is just tween of double, but you can use any other type here. But the point is that I have some begin value 0, 0. I have my end value 1, 0. I can also provide my final value scale wherever I want. It can be 10, 20, 15, or whatever. And then in my builder method of my tween animation builder, I just use transform.scale, and this makes this widget to like appear from 0 to 1, yeah, and now it's over after 2 seconds. But then if I select this, change this scale to 10, this will animate or interpolate this value on its own. So I don't have to actually do anything else than just, let me show you, set state scale equal to 10, and this will trigger rebuild. This rebuild will trigger rebuild of this, and this in result will trigger rebuild. Oh, that's hard word. Will trigger rebuild of this builder and animate this value from the previous value, which was 1, right? It wasn't 0, it was 1. So, and that now my initial value is 10, and I can animate this to 30, and I can animate this to 10. So if you have some kind of changing widget in your app that needs to like respond to some changes, and what is nice, again, this can be anything. This can be like a text. So if you need to animate some text from one value to the other, provided that you provided the linear interpolation function for that, then you can easily animate between values without any like some kind of additional animation controller or whatsoever. Pretty useful. I use it a lot. And I think I always start my animation with Tween Animation Builder. And if it's not enough, I switch to Animation Controller. Okay, we're like half hour in. And now we're going to move into some more advanced concepts. So this more advanced concept will be 3. So staggered animation, spring simulation, and material animations. So let's get going. Staggered animations is like this holy grail of animations in Flutter. And also this is pretty complex when you go into like official tutorial where you have like a, I don't know, 10 steps in order to make a simple animation. But I want to show you how to actually make this staggered animation simple without additional packages, because there are some great packages that allow you to make the staggered animations easier and simpler. But here we're going to focus only on some vanilla Flutter implementation without any additional features, but of course you can use some of them. And if you have some multiple animation steps, yeah, like in this case, these elements appear one by one, and you want to actually use a single animation controller for that, then staggered animation is what you need. So let me again show you this in this real application, because it looks a bit better than on a slide. So what happens here is very simple. Here the header appears, and then one by one each of the rows of this application go from the bottom to the top. And here we have some kind of a grid layout that allows to do so. Right? Nothing fancy, but of course you can make it a bit more complex, like all of them can rotate or can change their colors or opacity or whatever. But for the simplicity sake, I just added this like slight transition. So let me actually show you some very handy things about this animation. So the trick that I often use in such cases where I have a staggered animation is to actually create my own animated builder. Why my own animated builder? Because this allows me to have some kind of a domain specific builder and provide some values in a bit more readable way than if I would have to keep them in state or somewhere else. So what I do usually is I like delegate this the work to my specific animation builder, So for instance, I call this homepage animated builder, yeah, because this is going to build my homepage and animate this, and after that it's done. And what I have here is my custom transition builder. So here is this type definition, and this is a function that accepts context widget, which is very similar to typical animation builder. But I also have my home page enter animation class, and this is like this super secret that I wanted to share with you. And what I do, I just delegate to this builder, right? So builder is this function, right? And I just pass the context child and home instance of home page enter animation class, and I provide animation to that. And let me show you how it works. So my home page enter animation is nothing else than just a class, nothing else. Like not a widget, not a change notifier, not anything, just a class that helps me to keep in one place all the information that I need about widgets that are being animated in some kind of domain-specific way, right? So, for instance, what I know is that I have some header opacity changing. I have some row offsets, row second offset, and row third offset, right? So these are my properties that I need to have on my view in order to animate this. And I also need my controller to keep track of the current progress. And when I create this class, I just create some tweens. Again, this is not super efficient, right? Because I will create these tweens on each rebuild. But these are relatively lightweight objects, and like it doesn't cost a lot to just create them. So I just need to create for each of the animations that I want to have that happen one after the other, or like they are a bit overlaid. So for each of the steps, I create this tween. Yeah, so header opacity, row offset, row offset, row offset. Right. So all of like the first one is my tween of double, and then the rest are tween of offset. They all start with 0, or here it starts with 0, 5, which is like below the screen. Yeah, 0, 5. And for instance, opacity ends at 1 and offsets ends at zeros. Then I'm using this syntax that I've shown you before about tweens. I'm using .animate, and I provide my controller, but I also wrap this controller in a curved animation. Yeah. Then, so each of them is wrapped with curved animation. However, the curve that I provide is not just a simple curve like before, is in, is out, or whatever. It's actually a different curve. It's interval. So interval is a curve that just takes a part of a given, let's say, animation controller progress, right? So this will make this curve is in for the 0 and 0, 2 points of progress of animation controller. So animation controller will go from 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, right? And between 0 and 0, 2, this tween will animate this value, 0 and 1, with a is in curve, right? So only for this part 0 and 0, 2, this curve will be interpolated with this function and between these values. And the same will happen with offset. Yeah, so from 0, 15 to 0, 30 with curve is out. And let me actually show this in reality. So this was animated with linear opacity. All of the other will just like decelerate with ease in, right? Really nicely. And this is how it like really, this has this really nice behavior so that it makes this animation a bit smoother, right? And all of them happen in some kind of succession. And this succession is a result of these intervals being a bit overlapped on top of each other, right? So this first one happens from 0, 1 to 0, 25. However, the second one happens from 0, 15 to 0, 30. Yeah, so they are a bit overlapped, and this makes this succession like this kind of in steps, right? I hope this is clear for you, but if you have any questions, like feel free to post them in comments section, right? So this is like this trick that I've learned is very handy. Like if I have to use staggered animation, so for instance, if you have like a login screen where a bunch of elements appear, or when you have some kind of bottom navigation that appears, or bottom sheet that needs to show some kind of elements, then this kind of behavior is really nice. And what is nice also about this is that whenever I enter this page, yeah, this is being repeat. And also I made this animation controller to repeat so that you can observe this animation constantly, but you could of course stop it at any point. And then if you want to use this animation, you don't need to actually create any stateful widget for this. Of course, you had to create a stateful widget at the beginning, right? So you had to provide this animation somewhere, right? This animation controller. But all in all, you operate only on stateless widgets, which is much more simple. And then you have your home page animated builder, and it has its builder, right? And you could also, of course, use child if you want. And then you have this very domain specific object animation, and you can access like header opacity, row 1 offset, row 2 offset, row 3 offset. So you don't have to like think a lot. What property do I need to use? You don't have clutter in your code. You can extract this file to some other, this class to some other file and test it just like in isolation. So if you have some kind of specification from your designer, yeah, so that for the second 00, this screen needs to look like this, and for the second 05, this screen needs to look like this. So you can test this according to your design specification without actually running the application, right? Because you have some kind of description of what you want to animate. And this meaningful names is something that I really like crave for, right? This is something that makes the animations much easier. And also, if you want to add some other property, you don't have to modify the state. You just modify your, sorry, I forgot my keyboard shortcuts. You don't have to modify your state. You just add some other property to this class. You can change this. And because we are actually recreating this on each build, you don't have to hot restart your application. If you changed something here, it's being immediately visible in your application. Of course, you could make it a bit more efficient, and I suppose Krzysztof Sroka would like find some great way to optimize this. But in this case, where we have like a one-time only animation, I don't see a point in some premature optimizations. Okay, this was a lot about the staggered animations, but I hope that this like 12 minutes that we devoted to this will help you to actually start doing them, because I really think that this is something that makes your animations, makes your Flutter apps look a bit better, right? So when you open any like big application or some famous application, they always have some kind of staggered animations that happen in succession, in steps, and so on. If you take a look at some of the greatest examples like Reflectly, they all have this. And the next thing that I wanted to share with you is Spring Simulation. And Spring Simulation is something that I actually discovered recently, because before that, I actually was writing my own equations in order to make some kind of physics animations, especially with gravity. But it appears that there is this, no, Robert, this presentation is not with Flutter, but actually this application is being done with Flutter. And so I have a separate application. I'm going to post it later, but I didn't have time to finish. But this is something that I like find very amusing, that you have this kind of built-in classes in Flutter. So Spring Simulation is one of them. There is also a Gravity Simulation, and they all are in physics.dart library. This is built-in library in Flutter. And what it allows you is to have actually some Hooke's law simulation. So if you studied some engineering, you may, or have had some physics before, you may remember Hooke's law. And Hooke's law estimates or interpolates the spring behavior. And in Flutter, you actually have this. So for instance, if you want to animate something according to how it would behave as a spring, and many things in reality behave as a spring. So not only springs, but also some balloons, balls, some kind of devices, they sometimes behave like springs. And if you want to simulate some kind of a button or some appearance or some UI element moving around like a spring, maybe you have some vibrating element that needs to shake in response to some validation error, right? So you don't have to actually uh, like calculate the curves with which the element needs to vibrate. You can actually make a physical simulation inside of your application, and that will make this button to vibrate more naturally than you would ever came up with any sort of curve. So here you can see a very simple case. So what I do here is that actually I just move this element from position 0 to 600 with some initial velocity 10, and then I'm using my animation controller to animate this simulation. So this simulation requires some kind of timer, ticker that will move the progress the animation from 0 to end. And the end can be like indefinite. Yeah, if you would provide some strange values to the spring could vibrate indefinitely. But the point is that you have to, in such case, make the upper bound of your animation controller much bigger than it used to be before, right? By default, it's 1, so it will animate from 0 to 1, or like tick from 0 to 1. But you have to actually make it a bit bigger. So in this case, because the sizes and so on are much bigger, I made 1500 seconds, or 1500, maybe not seconds, but units. And let me show you this in reality. So I also make this like woo 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 spring here, and you can let me show you again the source code. This is very simple. Like you can just make some button and make the button like wobble around in your application very easily. And again, my initial position is 0, my end position is 600, and my initial velocity. So if I would make this, let's say 20, it would move a bit faster, and it would like go a bit further. If I would make this different, then the spring would go some different way. The important part is also the spring description. So for instance, if I would just make this spring a bit heavier, need to go back and forth because I did it. So now the spring is much heavier, right? So it doesn't wobble at all. Yeah. So it just goes to one. But actually, maybe this is something that you would like to have in your application, right? So you just don't want to make this like wobbly, but you want to make this spring a bit stiffer. But you can also make the stiffness smaller, and this will cause again some different behavior. Maybe let's make the velocity bigger. And this is the beauty of Flutter, where you actually can just change some properties. I think this mass is being like 10 times bigger, and this changes this. Well, again, very strange behavior. Let me go back to something that looked nice. Yeah, but you see the point. You can have fun with this spring, and also there is much more. Like if you go to the spring simulation, there is much more things here. Spring simulation. Then you have scroll spring simulation. What else? This is spring. If you go physics, gravity simulation, friction simulation, and clamp simulation. Yeah, so bunch of very useful stuff. Maybe if you want to make some simple game, this can be useful. Okay, and the final thing that I wanted to show you is something that you probably are aware of, which is material animations. And material animations is a library made by Flutter team and material design team, I think. So I think by material design team, but for Flutter. So this gives you a bunch of very useful transitions and animations that are compliant with the material specification. So if you are making some apps with material library, then this can be very useful. So for instance, sorry. if you have some kind of screen and you want to navigate between the elements of the screen. For instance, here you have some kind of container transform, the same here or here. It doesn't look so well on desktop, but it would look much better on the mobile phone, right? So this kind of behavior is not default in Flutter, so you actually need to use this library in order to do so. But like this is very easy to implement. There is a bunch of built-in widgets, and I often use, especially in my hobby applications or side projects, because customers usually have some kind of own behavior that they want to have. But in my side projects, I often use this kind of transition because it makes the behavior, the UX much more pleasant to look at. And maybe let's talk a bit about the elephant in the room, which is iOS junk issue. So many of you probably heard about iOS junk issue that makes the first animation when Flutter application starts on iOS a bit junky, a bit stuck. And I was trying to find some solutions back like 6-7 months ago when it first appeared, but since then there's no good way to do it. There was some ideas to use OpenGL or something like this instead of Metal, because this happens because Flutter had to transition to Metal on iOS, and on Metal there is no built-in shader caching, and this causes the Flutter, or actually the Flutter engine, to compile a bunch of shaders every time the animation appears, and there may be many shaders for even some simple animations like here. This is from I think one of the issues, so where you have like a rotating element, but there is like a lot of things happening actually. So the text is being rotated, the element is being rotated, some icon is being rotated, and so on. Some colors are changing, and this causes the shaders to the required shaders for that is a lot. So there is a project that you can follow with number 188 on Flutter repo, so that you can track the progress on some solutions to that. We hoped that there will be some solutions right now at the beginning of 2021, but still there is no like a viable solution to this, and I'm a bit worried that this can I'm not sure if it applies to Swift. I think that iOS engineers had some kind of like inside mm, how to say it. They were able to provide some pre-compiled shaders, or they have some tricks in their sleeves in order to make these animations much smoother with Swift. Yeah, so this applies right now, from what I know, from all of the applications cross-platform, only to Flutter, which is a very sad thing to say, but actually this is, for instance, in my case, in one of our apps, we had to actually disable the animations on iOS just because they looked so bad, and like we couldn't figure out how to optimize them because so many things were happening at once, and until now we couldn't bring them back. Okay, we spent almost 1 hour on the presentation, and there's like a lot of things that I would like to talk to you about, like some packages that I know and some tricks that I know about animations, but like we don't have enough time, and also my throat is actually dry right now. And if you want to learn more, there is a bunch of tutorials that I want to share with you, especially the recent video by Filip Hracek about developer designer and how to actually think about some UX things, UX aspects, animation aspects, some micro interactions, and so on when you create your apps. And I hope that this showcase of different techniques to animate helped you to, or made you inspired to try some of them. One special note is to the one of the libraries that were created, which is called Fanvas by creative creator, maybe not. This is his handle. So if you want to check out some really great tool to make animations in Flutter, I recommend to check Fanvas. So this is one of the samples there. And if you want to make some time-dependent animations, I highly recommend this animation library. Thanks a lot. Let me take a look at the questions, and if you have some, I will happily answer them.